Okay, guys, we're going to look at the scatter plot correlation and line of best fit uh, packet here. We're going to go through some of the problems together, and then whatever is left is going to be your homework. It's not going to be due tomorrow. It's going to be the day that I return, which is going to be Thursday. So you have a few days, but don't forget about it because I am checking it when I come back, and then I'm doing that because I want to be the one to go through it, see if there's any questions. You must have work shown, as always, with your homework. So let's take a look first at problem number 1. And yes, these numbers sort of go in order, and then they kind of jump around because I removed some questions that don't apply yet. And number 3 I crossed off because we don't need to do that one. So number 1, a baseball coach graphs some data and finds a line of best fit. The equation for the line of best fit is y equals 0.32x minus 20.51, where x is the number of times at bat and y is the number of hits. Well, that looks like important information, so I'm going to highlight that, or you can underline or circle. So x is the number of times at bat and y is the number of hits. That's information I'm going to need to know probably to solve this. So the question asks, how many hits should he expect from a player who is at bat 175 times? Well, how many hits? If I look back up here, number of hits, that's my y. So they're asking me, look for y. What is y when at bat 75 times, number of times at bat is my x, when x is 75. So I'm going to rewrite this equation they gave me, and I'm going to replace the x with 175. They say when x is 175, what is y? So I'm replacing everything. Notice I put the 175 in parentheses. That's because 0.32 is being multiplied by x. So when I replace x with 175, multiplication still needs to happen between these two things. You can show that by putting the dot for multiplication in between or by putting one in parentheses. Then we have to follow our order of operations, which means we need to do the multiplication before the subtraction. So 0.32 times 175 gives us 56, and then I bring down minus 20.51. So 56 minus 20.51, and that gives us y is 35.49. Well, notice that's not any of these 4 options. That's because you can't have a partial hit. You can't have a decimal of a hit. So we're going to pick the one that is closest, which is A, 35 hits. Okay, we're going to take a look at number 2. Number 2 gives us a table of data where they're giving us the average temperature and the date in April that the trees bloom. As a good rule of thumb, whatever's listed first in your table goes on your x-axis, whatever is listed second goes on your y-axis. So we'll be labeling this, and we're going to need to number it, and then we're going to plot these points. So if I read the directions, below is a table of data regarding the cherry blossom trees in Washington, D.C. A says make a scatter plot of the given data, and then B says correlation. So we'll decide, is that a positive correlation, negative correlation, or is there no correlation? So we're going to look at the graph to decide that. So I'm going to label my average temperature in degrees Celsius. And notice I left some space here so I can write my numbers on this axis. And then my y-axis is going to be date in April that the trees bloom. And again, leaving space for my numbers. So if I look first at my average temperature, I see my lowest number is 1.5 and I see my greatest number is 5.8. That means on this axis, I need to get up to at least 5.8. So I'm going to round that to 6. If I go up to 6 on my x-axis, then I know I can fit all those numbers on there. So if I count, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I have 12 boxes. If I need to get up to number 6, then every 2 boxes, I can put a number. So notice I'm putting my numbers on the lines. I am numbering the lines, not the spaces. And by the last line, I am going to be at 6. So now I have to decide the same thing for my y. I know that I need to get up to at least 28. So maybe I'll round that to 30. And I also have 12 boxes going that way. So if I think about that, maybe I'll take it up to 35 and see if I can count by 5s. So I should be able to do that. If my 0 is here and I count every 2, that would be 5, 10, 15, 20, 25, 30. So that would get me up to 30, which includes the 28. So that's what I'm going to do. So again, if I'm going to be skipping every 2 boxes, then I need to make sure the first time I number, I'm also skipping 2 boxes. A common mistake is people skip 1 and then start skipping 2. That would make the graph invalid. You need to keep the same scale. So skip 2, 5, skip 2, 10, skip 2 more, 15, 20, 25, 30. Again, I am numbering the lines and not the spaces. Once I have everything numbered, now I can go ahead and start plotting my points. So on the x, I go to 1.5, and then up to 28, put my first point. So here's 1, there's 2, 1.5 is in the middle. So 1.5 up to 28. I'm going to have to estimate a little bit, close to the 30. And I'm putting it out. And then 5.8 and 3. So 5.8 is close to the 6. And then up, not quite to the 5, and I'm putting another dot. So go ahead and plot the rest of your points and then check to make sure that yours match mine. Again, during this video, feel free to pause whenever you need to, or re-watch if you missed something. So when you are finished, take a look and compare that your dots are in about the same location that I am. Again, if you're not ready for this, then pause it until you've got everything plotted. So now we're going to take a look and see if there's a correlation. So if I look at my dots, they are gathered together, they seem to be trending, and they seem to be trending downward. So trending means there is a relationship, there is a correlation. What we have to decide is it positive or negative? Well, if it is trending downward, it's negative. If you are unsure as to why, make sure you take a look back at your correlation foldable. So let's look at number 5, which is in the lower left, and then we'll go back to 4 in the lower right. So number 5, Jared collected data on the ages and heights of a random sample of elementary school students. If he plots the data on a scatter plot, what relationship will he most likely see between age and height? So we're doing age versus height, talking about correlation. First thing I want to point out, let's look at our options. A is a negative correlation. B is no correlation. C is a positive correlation, and D is a constant correlation. So think about, one of those options was not on our foldable. Which one? Hopefully you said a constant correlation. That's because that's made up. That is not one of our answers. If you have not heard of one of the options, please don't pick that one. Usually that's a distractor. So now we're deciding between the other three. So what is the relationship? Most likely you'll see between age and height. So let's look. As age increases, as you are getting older, generally what is happening to your height? Is it going up, down, or is there no relationship? Well, I think we would agree there is a relationship. So our answer is not going to be that there's no correlation. So now we have to decide positive or negative. As age increases, typically you grow taller. So both are increasing. That's going to be our positive correlation. Okay, now let's look at number 4. The graph below shows the relationship between the distance in miles a delivery truck traveled and the number of hours that each delivery took. So distance in miles is on the bottom, number of hours is our y-axis. Which of the two given points would be the best to use to calculate the line of best fit? Essentially what they're asking is, which two of these points fall on the line that's drawn? They're not asking which 2 points are just there, which 2 fall on the line of best fit. So the easiest way to do that is to start graphing and see. So 500, go over to 500 and up to 11. Well, that's going to be right here. There's a dot there, but that dot is not on the line. So I'm not even going to try that other point. I want both dots to be on the line. 309, so go over 300 and then up to 9. So once again, there's a dot there, but that doesn't matter. I want a dot that falls on the line. Not going to be that one. 400 and up to 9. I'm getting closer, but I'm still not on my line. So hopefully this last one, both points will work. If I go over to 300 and up to 7, okay, I'm on the line there. That one works so far. Let's check the other one. Over to 600 and up to 10. And we're on the line there too. So that one checked out. So our answer is D. Okay, flip the page. And number 6 says, the graph shows the weights of dogs and the time it took the same dogs to complete an agility course in seconds, which shows the line of best fit for the data. So each one of these graphs has the same points. They want to know which one drew the line that best fits those points. So if I look, D, that line does not fit those points at all. That is not a good fit. If I look at A, the line is going the same direction as the points, but it's way above all of them. So that's not really a good fit. If I look at graph B, again, the line's going the same direction, but now it's way below all those points. And if I look at C, the line's going the same direction, and it's going just about through the middle of the points. That's what I am looking for in a line of best fit. So the answer is C. Number 7. A high school principal wants to predict the number of students who will drop out of school so he can get funding for support services. So here's the year. Here's the number of students who dropped out of high school. He determined the equation that represents this data is y equals negative 10x plus 216, where x represents the number of years since 2004. Again, important information. I'm going to highlight that or underline or circle. And y is the number of students who drop out. Also important information. Use this equation to help him predict the number of students who will drop out in 2012. That's what I want to know. So I want you to pause the video and figure out an answer And when you think you have the answer, then I want you to unpause the video and see if you were right. Welcome back. So if I want to know the number of students who are predicted to drop out in 2012, 2012 is not the number I'm putting in for X. X represents the years since 2004. So I need to figure out how many years is 2012 after 2004. Well, 2012 minus 2004 tells us that 8 years have passed. So I am replacing X with 8. So I'm rewriting this formula, negative 10 times X. So when I replace with 8, it's negative 10 times 8 plus the 216. Multiplication happens first. And then I can do the negative 80 plus 216. So negative 80 plus 216. And that should give me 136 students. So if you picked C, that is correct. If you made a mistake, first thing I would check is, did you replace X with 8 or did you plug in 2012? So read carefully. Okay. Question number 8 asks which graph represents a positive correlation. So take a look at those 4 graphs, decide which one is a positive. Letter C. All the points are trending upward. That is positive. What type of correlation is A? Hopefully you said negative. B is no correlation. And for now, we're not going to worry about D. That doesn't look like anything we've discussed so far, so that should have been an automatic, not that one. Question number 9. The scatter plot below shows the average yearly consumption of bottled water by people in the United States in 1990, starting in 1990. Using the line of best fit, predict the average consumption of bottled water in the year 2000. So what I'm going to do is come over to the year 2000, travel up till I reach the line of best fit, right? Until I hit that line that's drawn. And that's where my dot would be. So then to figure out what that is, I'm going to travel back over to my y-axis and determine what number is there. Well, this is 10, skip to 12, 14, 16, 18. So up here would be 20, which means between 18 and 20 is 19 gallons, D. So we're using the line of best fit they drew to make a prediction. Okay, from here, you guys will need to complete the rest of the packet on your own for homework. Again, due the day that I return on Thursday. Make sure that you show all work. One thing that I want to show you is when you are labeling, again, this will be on your x-axis, this will be on your y. And if you notice on our y-axis, the numbers are very large. So if you start with 0, you're not going to have any dots until you get way up here. So there's this thing that you can do where you can create a break. You can create a break in the graph shown by this little lightning bolt, and then you can start with a number like 300. Then you can decide what your scale needs to be to get up to at least 420 there. So label both axes, write your labels, do your scales, do your scatter plot. Okay, and then the rest of the packet should be pretty self-explanatory. So wherever you can show work, the expectation, as always, is that you show your work. Okay, guys, have a nice day.